So in last session we have seen how we use merge algorithm, right? So today we will see how to sort, actually means how merge sort is being implemented. So today's topic is merge sort algorithm, right? So merge sort will be applied on the array, right? So I need first index of the array, that is represented by I. I need last index of the array, I and with I and j, and then I need array name to pass, right? So I will call it as A. A is array name, I is first index of the array, j is last index of the array, right? So in any sorted, because we will be applying it with recursion, so in any sorting algorithm, first condition is how it will get terminated. So how it will get terminated if I is equal to j, means if there is only one element, then this algorithm will get terminated, right? So what we will say, if there is only one element, then return, right, a of I, means that element itself is sorted, right? So that is if part. This I have explained in last video or last lecture also, right? Then we go to else part. Else what we need to do, first we need to find out middle element, mid, that is I plus j divided by 2, right? Floor value means I need integer value of that, right? So this we have seen in last class also, how we divide it, right? So that procedure I am telling, right? I plus j by 2, and then we will divide, so it is, we will get mid, right? Now what we have to do, we have to again call this algorithm only, that is called recursion also. So merge sort, right? And then a I, same algorithm with new parameters, a I till mid, means go to the left side, this thing, divide it till mid, and again do the same procedure on the algorithm, go to the left side, right? These all things has been explained in last video, right? So merge, right, a I mid, and again call same algorithm with merge sort a, then mid plus 1, next element, then mid till j, right? So this is like when we are dividing from first to last element till mid, right? And then we after mid also, means if we apply it on this array from 1 to 7, then it will make one part from 1 to 4, second part from 5 to 7, right? And after division has been done, and we will divide till when we reach till one element, that also has been covered in last class, right? So after all this process has been completed, what we will do, we will do merging of the algorithm, right? Means after dividing, we have to combine these merge step which we have seen in last lecture, right? So these merge step has been implemented like this. So I, this is mid, and k is mid plus 1, right? So we will call this merge algorithm here, right? I will just write first and then I will show you, right? So we will call this merge algorithm here, which we have seen earlier, merge with the parameters a I mid plus 1 till j, right? This algorithm has been called in this part, and then after this has been merged, return a, right? Return a, right? Here this else has been finished, and here this merge sort algorithm has been finished. Means in merge sort, actually we are what we are doing, this is recursive call, this is called recursive call. So here recursion has been applied, right? Function is calling itself. So from I to j I have divided till mid. So on the left hand side I have applied merge sort, then on the right hand side I have applied merge sort, and till I reach till these nodes, right? Then we need to combine them together, right? So that is taken care under merge algorithm, right? So merge algorithm we have already covered. So this is that merge algorithm which we have covered, right? So this algorithm will be called inside here, right? So we can match parameters with this, and this is how this complete merge sort has been implemented. So what's important is, as we have seen in the last class, this merge algorithm will take order of n time. Now we'll see this, right? Say this algorithm completely will take uh, tn time, right? So if it is having only one element, it will take order of 1. If this complete array is taking time n, t of n, so this part where it is being divided in half, that will be t of n by 2. Second half will also be t of n by 2. And this merge algorithm, as we have seen in last lecture, it will take order of n. So how complexity has been defined, means how we will reach till n log n, that I will explain, right? Till with that we will conclude the algorithm, right? So this is how we do it. So while writing time, here tn is time taken to execute the algorithm. It is order of 1 when n equal to 1, means when there is only one element, it is order of 1. And otherwise what it is? It is order of 1, right? Otherwise it is order of 1 plus t of n by 2 plus t of n by 2. I can write it as 2 t of n by 2, right? And this n also will come plus order of n otherwise, right? So the recurrence relation for merge sort will come as t of n equal to order of 1 and order of n. So we will merge it as order of n. So we will write it as 2t n by 2 plus n, right? So this is the recurrence relation for merge sort, right? Now we'll see how we get the calculations done, right? So if this is t of n, so if I need to write t of n by 2, t of n by 2, how I will write? I will replace n by n by 2 everywhere. So it will be 2t, and here n by 2 square will come, right? And here it is n, right? So then in here it n by 2 will come, right? So now if I fit this t of n by 2 here, so what it will do, 2 is outside, and I replace 2t n by 2 square, right, plus n by 2, right, and plus outside, right, outside, and this has been copied here. Now if we multiply 2 here, so it is 2 square t n by 2 square, 2 and 2 will get cancelled, right? So it is n plus n. So till second step, in second step it will come as 2 square t n by 2 square plus 2n, right? So why I am focusing on second step? You can repeat it for n by 2 square also. In third step 2 cube will come, right? So in second step it is taking 2 square and 2 here, right? So say to terminate the algorithm we ran it k times. To terminate the algorithm we ran it k times. So to get it terminated, this thing n should reach till 1, right? T of 1, right? This order should reach till 1, right? So what I mean to say n is equal to, if I run it k times, so how it will look like? It will look like, if we run it k times, it will look like something like this: 2 raised to power k t n by 2 raised to power k plus k times n. So if we ran it k times, so say to get, after k time it got terminated, that means this thing became 1, because t of 1 is 1 only, right? T of 1 is 1 only when there is only one element. So t of 1 is 1 only, right? So to get this thing terminated, n by 2 raised to power k should be equal to 1. That means n should be equal to 2 raised to power k, and if I take log to the base 2 both side, so it will look like this: 2 raised to power k, this k will move forward, so k will be, because base and argument is same, this it will take value as 1, k will be equal to log 2n, right? Now I will replacing this k with log 2n. So this is log to the base 2n t, this became 1, plus k is log to the base 2n and this n, right? So if base and argument, right, if we are taking this to the power of log and the base is same, we can directly write n. This is property of log only. So n t of 1 plus this n, I am writing it here, n log to the base 2n, right? So t of 1 is 1, so it is n plus n log to the base 2n. Since n log n is greater than n, so while writing order we will take bigger value, so we can write its order of n log n. So that is how time complexity of merge sort comes, right? So this is how time complexity has been derived in merge sort, right? So the time complexity of merge sort, so I will just revise all these things, right? So this is what we have seen in last lecture, right? Time complexity of merge algorithm is order of n. Time complexity of merge sort is order of n log n, right? And then there is one important step where we define comparison. If we have two different size arrays m and n, if we are merging, then number of comparison is m plus n minus 1, right? If we take same order n and n, then we will write it as n by 2, that comes as order of n, right? But total number of comparison, right, will come as comparison plus number of moves, because we will be copying complete array here, so it will anyway will take n time, number of moves will take n times. That's how this time complexity of merge is coming order of n, right? So this is how we see merge sort is being implemented, and this is how n log n, right? So it is like fastest sorting algorithm also, quick sort also comes in same place only. So this is the pseudo code for merge sort, right? So hope everyone understood, right? Thank you. See space and space complexity of merge sort also, right? So as we have seen, the time complexity of merge sort comes as order of n log n, right? So what about space complexity, right? Space complexity is merge algorithm, the space merge algorithm is taking plus stack space, right? So stack space is this space only, that k times when we ran it, right? So this is space only, stack space only. So this is log to the base 2n. But remember, we have seen in merge algorithm, like this algorithm is taking extra array, right? We are storing in extra array, right? In here also we are storing complete in extra array, right? So that will be of size of input only, right? So that will take n size array to take different output. So that's how space complexity of merge sort is order of n only, because n is greater than log n. So space complexity is order of n only. So this is how time and space complexity of merge sort is being defined. And the algorithm which is taking extra space as storage, that is called outplace algorithm, right? When an algorithm take extra space as a storage, then that algorithm is called outplace storage algorithm, right? So this is all for merge sort. Thank you.